So in this Pythagorean Theorem in 3D, this first problem here is actually an excellent real-world problem. The Great Pyramids of Giza is what we're looking at here. One of them, the Pyramid of Khufu, has a square base with sides of length 230 meters. The vertical height of the pyramids is 140 meters. Now, first of all, it helps to kind of draw this because our vertical view of it is not very helpful. We want to see it in 3 dimensions, so we're going to try and do the base first and do each of the sides, and notice that the base the sides of the base are pretty easy. That's 230 meters, and we can figure that out very easily. But if we kind of just take a look at, we're looking for that green side there, we're looking for the height of the triangular face, which is a little bit more challenging to figure out. We do know that if we look right in the inside, if we kind of go into the base, right to the very center of the base, and we look at the height from the center right up to the point at the top, that height there is 140 meters, that purple height right there. Okay, so we can see already there's a right angle triangle created by the height and the center of the base. The base is of course 230 meters, which means that if we are going in from one side into the center, we're creating another square in the which is just 1/4 of the bigger square base, which means that half of that is only 115. So 115 is the number we've got to work with, and that means we have the base of our triangle, right? And we have the height of our triangle. So we're looking for the hypotenuse. We're looking for c squared is equal to a squared plus b squared, right? We don't actually need to find out anything else here. In some problems, you might actually need to find out a second piece, but I'll deal with that in another video. In this video, I'm just going to show you we just extract that, we square both sides, we get c is equal to the square root of a squared plus b squared. We're going to say that our height is a squared, 140 meters, and our base of the triangle is b squared, which is the square of 115, which is half of 230. So numbers this large, use your calculator. You can of course use the time if you feel you need the practice to work this out by hand. Certainly do. 140 times 140 by hand is not a difficult task. It's something you've already learned and something you could do on your whiteboard if you don't feel like grabbing a calculator right now. But using a calculator, I used a calculator because I'm making a video here and I don't have the time. So 140 squared is 19,600, and 115 squared is 13,225. So that's a pretty big square root. At this point, again, of course, you could make a factor tree when you add these together. First of all, do add them together. You could make a factor tree if you so chose. It's going to take you some time because the square root of 32,825 is a rather large number, and it's also an irrational number, so it's going to be tricky for you to actually do it. I strongly encourage using a calculator for this. You have a square root symbol on the calculator. If you're using Google, use the string SQRT, open parentheses, 32825, close parentheses, and hit enter on Google, and that will actually give you the square root of 32,825. So that's pretty. Google is a pretty easy calculator to use. Our square root there is approximately 181.17. It's an irrational number. It goes on forever. But we're being told that to the nearest tenth, so we need to round up to 181.2, and that is the height of the pyramid in Giza. So enjoy that problem. The next problem here is a little bit easier, but it also gives us something to work with. This is where we need to use 2 triangles, okay? Because we need to find the diagonal of the rectangular prism D, and we don't have a base or a height. So we need to find. We do have the height. We have the height of the square there. There's our height, and that is, of course, indicated there at 6. But we don't have the base, and we notice that the base actually is the hypotenuse of another triangle created by the rectangular base of the prism itself. So we can actually, we're going to label that C first of all. We're going to say C squared is equal to A squared plus B squared, of course, because the base of the prism is a right triangle right there, or creates a right triangle. So C squared is equal to 2 squared plus 3 squared. So C is equal to the square root of 4 plus 9, and 4 plus 9 is 13. Leave this in your square root, because you're only going to be squaring it again. So just leave it in the square root. No need to actually find out what the square root of 13 is at this point. We're just going to say that C is equal to the square root of 13, and we're going to use that in our and we're going to say in our other triangle, because this is also a right angle triangle, and we're going to say D is equal to the square root of 13 squared. Now that's interesting, because you know the square root is cancelled out by the square, so that's plus 6 squared, of course, from the height. So D is equal to the square root of 13, because it just cancels out the square, the radical, plus 36. 6 squared is 36. 13 plus 36 is, of course, 49. And 49 is a nice rational square root. We like working with that. And the square root of 49 is just simply 7. And I'm going to leave that for now. There's a few more problems on there that you should definitely try.